This session is on advanced GORM. So my name is Graeme Rocher. I am the project lead of Grails, for those of you who don't know. And in this talk, essentially, we're going to go through a few of the more advanced topics around GORM. So this kind of talk assumes you know what GORM is and have used it before. Is that the case with everybody here? Pretty much? Yes? Okay, good. So we'll look at understanding some of the GORM internals, how GORM fits together. Then we'll talk about GORM standalone and how you can get GORM going in a standalone context outside of Grails, which is a good way to play with it if you don't want to spin up a whole Grails app. We'll talk about some tips and tricks with GORM and some more advanced features. We'll jump into trying out some MongoDB. We'll talk about unit testing, and probably after we've done all that, we may even be out of time, but we might have to skip the unit testing part. We'll see how we go. I have crammed a lot of material, so we will do the summary and Q&A at the end. So anyway, what is GORM? So I like to call it a multi-data store query layer nowadays. The name GORM obviously historically has significance in terms of being an object relational mapper, but that is kind of a misnomer nowadays with all of its capabilities also being equally applicable to things like MongoDB, Cassandra, Redis, and Neo4j, amongst others. So what does it do? It provides basically a way to take an object, a class, and map it to an underlying data store, and then it provides a query API automatically for that class. So instead of you having to write a repository or a service where you handcraft your SQL or your HQL or your whatever, you basically just call dynamic finders that exist, use criteria queries, persistence methods, and so forth that are already built into the persistence framework. It has integrated validation, so entities are validated prior to being persisted based on constraints and validation constraints that you define. And generally, it provides easy access to the native underlying APIs. And we endeavor to do that as much as possible because particularly in the NoSQL data stores, it often makes far more sense to use the native APIs than it does to use GORM APIs. So easy switching between one or the other. So I'm going to talk to you a little bit about GORM internals first, so you can get a bit of an understanding of what makes GORM tick. So first of all, the source code for GORM is we didn't name the repository GORM because this was during the time where we decided to make Grails multi-data store. So the repository is actually called Grails data mapping. And you can find it at that link. Yeah? So this is where essentially the source code for GORM exists. So GORM has gone through a kind of evolution. In the early days of Grails, it was essentially just a big bunch of metaprogramming that programmatically iterated through a bunch of classes and added via metaprogramming methods to classes. That is completely not the case now. Nowadays, it's a set of AST transformations. The methods are actually added to the bytecode, so you can actually call GORM methods from Java code. They are visible as static methods, public static methods, things like list and so on, as are the instance methods. So you can actually call save from Java code if you have a precompiled Groovy entity. GORM is heavily tested. We have a TCK test suite, and it's powered by Travis CI. Anybody used Travis CI before? So it's a publicly, Travis CI is this build tool, kind of like Jenkins or Hudson, except it's in the cloud, and basically it's free for use for open source projects. it's very handy because it allows us to build concurrently our different implementations. So we have a build matrix with different implementations, different build tasks, jobs for Hibernate, for Hibernate 4, for MongoDB, for Redis, for Cassandra. The test one is essentially there's an in-memory GORM. So there's an implementation of GORM that operates on top of concurrent hash map, just a Java concurrent hash map. And that is equally an implementation of GORM. So we have various implementations. And one of the benefits that Travis gives us is if you contribute to Grails, i.e. you contribute to our repository, that often comes in the form of a pull request. Yeah? So you want to fix something in GORM, you make a fork of GORM, and you make your change and you send us a pull request. What Travis does is it'll automatically build your pull request so that we know that the changes you make don't break anything prior to merging. So it provides that advantage of other CI systems in that we can automatically test incoming pull requests, incoming changes from the community without worrying about whether they're going to break. You can see that in action. In fact, if I open this up, you'll see our Travis CI instance and the latest job. Paras Lakhani is our most recent external committer, and he is contributing heavily to GORM for Cassandra at the moment. He is amongst 2 external committers that we have working on GORM for Cassandra, and he just made a commit, which was 47 minutes ago. No, it ran for 47 minutes. Sorry. When was the commit? Well, it'll probably appear on GitHub if I look at this commit message. The commit was 2 hours ago, and you can see that it ran his changes against all the data stores, ensuring they work on Hibernate, Hibernate 4, MongoDB, Redis, Cassandra, and so on and so forth. We actually need to add Neo4j to our build matrix. It should be there ready. And you can go through our build history and you see pull requests and so on and so forth. So that is how GORM is built. We have a bunch of developer documentation on GORM, which may be useful if you consider contributing. So in this link here, you will see there is a developer guide, documentation on the individual implementations, and a reference to the core API, links to the Java docs and so on, and a developer guide on how explaining the internals of GORM and how things fit together and so on and so forth. So that might be useful as a reference because it can help you understand the internal structure of GORM and how it works. There's some important sub-projects. So GORM itself is a multi-project Gradle build. And there's implementation-specific sub-projects for MongoDB, for Hibernate, and so on. But the abstract implementations, the abstract superclasses that power GORM essentially can be found in Grails Data Store core and Grails Data Store GORM sub-projects. And then we have a TCK. So the TCK is a set of Spock specifications. And these Spock specifications, I think there's around 300 of them, are run against every single implementation of GORM. So the same set of same set of tests are run against Redis, MongoDB, Hibernate, and so on and so forth to make sure that the behavior across the different implementations is the same. Yeah. Those are important. If you want to see how bits of GORM are tested, just check out the TCK. Obviously, each individual sub-project like Hibernate and MongoDB has also their own tests. We have tests for example, features that only work on a specific data store, like geospatial querying for MongoDB will have its own set of tests separate from the TCK. because that's something that will never work across all data stores. So these are all only tests that work across all data stores. And actually, we had this might be interesting to look at. We had a recent pull request from somebody. So a new test case for subclass fields. And you'll notice that this is a pull request and that it failed on Travis. And the reason it failed is because he provided a new test case, and the test case works in Hibernate and Hibernate 4, but fails miserably in MongoDB, Redis, Cassandra, and everything else. So we haven't merged this one yet, because until those implementations catch up or we add those features, it's not mergeable to the particular test case in question. The pull request, one approach we can take to this is to say, okay, well, add the test only for Hibernate. If we agree we're not going to support that feature across. But if it's agreed that it's a feature that we want to support across all implementations, that all need to be fixed prior to being merged. Okay, so I'm just going to go through a quick code walkthrough of what GORM is and how it's structured. So this is the source code of that repository I was telling you about. And you can see that there are all these subprojects, and some of them are much more mature than others. So as I said, the most mature implementations currently are MongoDB, which is already at version 3, Hibernate 4, and Neo4j, which has already gone 1.0 GA, and they're working on 2.0 right now. Redis, which has got a 1.0 out as well. And the Cassandra guys working on the Cassandra implementation are very close to doing the 1.0. So that's pretty exciting. So in terms of the structure, as I said, the most important projects are Grails Data Store Core. And in here, you will find the fundamental core APIs that make GORM work. For example, the abstractions around querying and criteria, the core engine pieces, abstract interfaces for how to connect to an underlying data store, and an interface for a session. So a session in one data store is, this relates to a Hibernate session for Hibernate, but in another data store, it might relate to a MongoDB request start, request done instance. So depending on the underlying data store, there might be a session wrapped around it. And there's abstract implementations of that. So and then there's various utility methods around creation of proxies, querying, the core interfaces around querying in terms of criteria queries, so on. So everything that is core to GORM, this is the source code. A lot of this you will reference in your Grails applications. And then in terms of more direct interaction that you as a Grails user have with GORM, that all happens in the Grails Data Store GORM subproject. So in this subproject, you'll find the public API packages with things like criteria builder, detached criteria, which is what powers where queries, page result list, which is gives what is returned from a paginated query, the dirty checking implementations. And then in here, under org.grails.datastore.com, you'll see some interesting classes. These ones are called GORM Static API, GORM Instance API, and GORM Validation API. So GORM Static API is essentially a class, and this is the class that provides all of the static API, what makes GORM work. So for example, you will find the list method in here, which is what happens when you call person.list. Yeah, it'll call this method. Yeah, or you'll find the read method or the get method. When you pass person.get and an ID, it'll call this method. Yeah, so this is essentially the core functionality of that static API. And when you call a dynamic finder, it'll go through the method missing implementation, which executes the dynamic finder, finds a match, and invokes it. Yeah. So this is how dynamic finders work. The font, yeah. There's probably a way to do this automatically in IntelliJ. I can't remember right now. Is that better? Yeah? Okay. So yeah, you got find all, and so on and so forth. And then the GORM instance API class, these are all the methods that, for example, when you do object.save, so you'll find in here the save method and its implementation, the insert method, the dirty checking methods to check if an object is dirty, the refresh method. These are all the instance level methods. And finally, GORM validation API is the part that adds validation. So this adds the validate method and so on and so forth to. So it's really, if you want to see how GORM works or how a particular method works, you can easily reference the source code and see these classes in action. So each, and sometimes, depending on the data store, so for example, in MongoDB, if I look at GORM static API, and I look at the subclasses of this, you'll see that there are subclasses often per data store. So for example, there's a Mongo GORM static API, and you'll see that it extends GORM static API and provides a bunch of new methods. So when you call person.db to get hold of the MongoDB data reference, or when you call, what's an interesting method? So yeah, there's an aggregate method which allows you to tie into the MongoDB aggregation pipeline. There's a search method for doing full-text search queries. These are all additional methods that are MongoDB specific, yeah? Which are added in addition to the parent class GORM static API. So that's a basic code walkthrough of the way. So what happens with these is when a GORM entity is identified, and in Grails that happens when it lives in the Grails app/domain directory, or it can also happen if you annotate an entity with @entity. What happens is the AST transform essentially wires in these classes into your class, so using a delegation pattern. So there'll be a local GORM static API reference that is all the static methods delegate to. Yeah, so that's what happens, and that's why we're able to see. That's why Java is able to see those methods now, because they're actually statically referenced in there and delegate to them. So that's how GORM works essentially. So GORM is a great area of Grails where you guys or people, the external contributors can contribute to. It's huge and it's sprawling, and there's far too many NoSQL and alternative databases out there for us as the Grails team to work on ourselves. So as I said, in the case of Neo4j, there is a chap from Neo4j working on it. In the case of Cassandra, we have 2 external committers, and so on and so forth. But we need help. So it covers loads of data stores, and it's a great area to contribute. So if you're interested, some ideas on the horizon that we would like to work on or find time to work on. Native multi-tenancy in GORM. So multi-tenant applications are in the cloud are becoming more and more common. So it would be nice to have GORM natively handle multi-tenancy without you being able to do anything special, just specifying your tenant ID strategy. It's a GORM implementation for Elasticsearch, so that could be fun. Definitely be a fun project. There's been various spikes and efforts that have emerged on doing that, but none of them have really come to fruition. And a GORM implementation on top of HBase could be fun. Hadoop, Hadoop big data applications, pretty relevant nowadays. So again, another thing that we would like to see coming in the future. So we'll probably get to work on these things eventually, but they will come to fruition a lot quicker with contributions from the community. Okay, so let's talk about GORM standalone. So GORM is not just usable inside of a Grails application. As of 2.4, it's now possible to use GORM outside and in Groovy scripts inside Spring Boot. And it took a while to actually make this happen. It was one of our most voted for Jira issues for a long time, because it actually required a lot of refactoring and modularization work. And we got there in the end. GORM is now, and the Grails data codebase is completely separated from Grails itself with minimal set of external dependencies. So it's a lot simpler to set up. So how does standalone work? So in the case of normal Grails app, as I said to you before, is that you got a domain directory, so we know that those classes in there are Grails domain classes. But if you're using standalone, you actually need to put on the entity annotation in similar fashion to JPA or other or Spring to identify a particular class as being a domain class. And that annotation is more than just an annotation; it's an AST transformation. So it applies all of the necessary behaviors to that class during compilation time. And that's why it's needed more than anything else. So once you have done that, to get standalone running, you don't necessarily need to use Spring Boot. You can do it just as easily in a Groovy script. I posted some gifts in my public GitHub account, and here, for example, is the how to set up Hibernate. So you have to reference Grails data store GORM Hibernate 4 latest release, and you have to pull in a database driver. You could put it in MySQL and connect up to MySQL, or you could do whatever you want. And then within there's a Grails.orm.bootstrap package that you have to import, and a class called Hibernate Data Store Spring Initializer, rather long in the tooth. Anyway, that one you new up with and passing in your domain model. In this case, I'm just passing one domain class. And then you pass configure for data source. You have to create a JDBC data source. So in this case, I'm just using a driver manager data source. Call configure for data source, and it'll set GORM up, and you're ready to go. So where you put this initialization code is kind of application specific. I no idea where you would necessarily put this. It depends on the application. It depends if you're using Spring, and it depends if you're using Spring Boot. If you're using Spring Boot, we have a set of Spring Boot plugins, which means you don't have to do any of this. It just configures it automatically, and you don't have to write the setup code. This is only in the case that if you're using GORM in a Groovy script or in a completely different application. And the same thing with MongoDB. The only thing is it's a slightly, instead of Grails.orm, it's Grails.mongodb.bootstrap, and there's another class called MongoDB data store Spring Initializer, and you call the configure method, and it sets it up. So let's have a little demo of that up and running here in my app. So I created a Gradle, just a normal Gradle build. So this is a Gradle project. Actually, I don't need that anymore. And basically, what I have here is a single GORM entity called person with some properties. And then I've created a Spock spec here. And it has a setup spec method, which creates my Hibernate data store Spring initializer. And it's a driver manager data source, and then calls the create people, sets that up. And then I've got some, the naming of this is kind of irrelevant, but some GORM interaction. So if I run that, you'll see that it will load GORM inside of my Spock test, in this case, and run the tests, and it passes. Yeah.
Do you have to call the data store initializer for every domain class you have?
No. So if I had more than one, you would I would have person and dog and et cetera, et cetera. You can also pass in a list collection. So it has varargs or a collection of domain classes. So yeah, it's really that simple to get it up and running. And then you can use it in any context that you want. So as I said, in the case of Spring Boot, you don't need to write any of that setup logic. The Spring Boot plugin for GORM and for MongoDB will actually just use that same class behind the scenes. It just simplifies it a bit. In the case of Spring Boot, because we have the auto configuration feature, all you have to do is specify dependency on the Grails Hibernate for Spring Boot jar, and then you add your entities with the annotation on, and it'll just automatically configure it. You don't have to do anything. Yeah. If you want to change your database settings or let's use MySQL or whatever, you just use the same way as described in the Spring Boot user guide. So it's typically specifying an application YAML with your, there's various ways to do it. But that's all documented in the, there's no special way for GORM. It's exactly the same as you configure a data source in any old Spring Boot app. And it will just back onto that. And in the case for MongoDB, in the same thing, instead of Hibernate 4, we have a dependency on MongoDB, and again, it will just automatically configure it and load it up, and you don't have to do anything. And the same, because we use Spring Data underneath GORM, because MongoDB for GORM for MongoDB, uses Spring Data MongoDB underneath, the configuration mechanism for configuring it is exactly the same as Spring Data MongoDB. So you don't have to do anything different. You just follow the Spring Boot docs to configure your connection settings, and you're done. Okay, any questions so far? Excellent. So let's look at a few tips and tricks then. In this section, I kind of just pulled out some kind of lesser used areas of GORM that I think are really cool and innovative, and that people don't use enough and should, and that I really like, and that I can share some ideas. So one of those things is where queries. So who's used where queries or uses where queries? Okay, a few hands. So who's never used where queries? A few hands. Okay, so where queries are like just awesome. They're type-safe composable queries. So basically, there's a method called where, and you pass in a closure. And in there, you just use the same kind of syntax you would do if you were using kind of Groovy's normal collection API. Yeah. So you just use native operators. So in this case, I'm saying last name equals Simpson. And that if I make a spelling error and I spell last name incorrectly, the compilation will fail. And what gets returned is an instance of detached criteria. Yeah. So that where statement there is not actually executing a query at that point. It's just creating what's called a detached criteria instance. And that detached criteria instance is completely separate from any kind of session or database connection or anything like that. It doesn't actually do anything. So you can create these detached criteria instances as properties of other classes, as variables in another context, and pass them in. You can share them, you can pass them around. It really doesn't matter because there's no connection to the database. Yeah. Once you get to the step where you actually want to execute the query, the detached criteria class has a bunch of methods to do so. And so in this case, I'm calling a list. So I'm going to do some demos of where queries because I think they're pretty cool. And we'll see how time-consuming is that. OK, so I've already got one example here, which I think is kind of interesting. So I've got a where query here, which does a like operation. So it's saying first name, like, and it automatically translates the regex operator into a like query. So in this case, I'm just using a like syntax on this side. And you can see that it's checking that, testing for all people that have a first name that starts with the letter B. And doing a count on them. In this case, look at my data, we've got 2 of those, Bart and Barney. So we run that. And it just works. So the cool thing is with detached criteria is if we, because there's because they're like detached and not actually executing queries, we can and also they're immutable. You can compose them, so I can say query.where and do another where query on this, and I can say age is greater than 15 or 18, and create a completely new. You actually have to use the result of that because, as I said, it's immutable. It actually returns a new query, and then when I do new query.count, that'll equal 1. Should be any one of them. And there is any one. So that's taking essentially my first query, and then I'm chaining it onto another query. Yeah. So you can create kind of and the other thing you can do is, as I said, these can be defined as properties. So I could define this as a property somewhere of my class and reuse that. So I don't have to. I can share it amongst methods, share it amongst different methods. Oops, probably broken something. Oh, well, you can. I'm not going to figure that out right now. But yeah, you can share them amongst methods. You can also define them as static variables of your class. So a quite common pattern is to define where queries in this way. So where we actually define them at the class level, and then you can do person.simpsons.list, yeah, as static variables. So you can compose them in between different queries. And what you can also do is, in Grails 2.4, we added a whole bunch of possibilities to do what are called subqueries. So you can name this query something more relevant, like first people with names that start with B. And then you can have another query here that does a not in query, and you essentially do people that start with B. And what you can do is you can reference, with detached criteria, you just have to do, so this person domain class has a last name property, And because it does, I can just do dot last name, and it'll essentially not in. Is that right? I'm gonna. The not in method. Attach right there. Yeah, so not in last name. So basically, in this case, I'm saying I want to find all the people where their last name is not in the result of the previous query, and we'll do a subquery, a query combination of the two. Yeah. In this case, what will actually happen is it'll lead to only returning Fred. Yeah, let's see. Okay, so new query. Yeah. So the only result from this new query is, and we can verify that, would be new query dot get these types. Yeah. Need to. What is that error? That's because get is supposed to be taken argument. No. It's supposed to take an ID. No, it's a subquery. This should. Yeah, I'm not gonna monkey with this, but I've got something wrong in my syntax. But anyway, trust me. You'll have to trust me on that one. But yes.
So since you were flipping between get and list, that reminded me to ask.
Yeah.
What's the difference between the two? What do you actually?
So get.
When do you use one versus the other?
Get will get a single instance, so only one result, and list will return all the matching records. Yeah. Yeah. I think not in last time. It's not liking my subquery criterion. Anyway, I'll I'll post examples, working examples after my talk with in Git, so don't worry. Yeah, I mean, you can do a lot of, in terms of composable queries. And the cool thing about where queries is, if I just pull up the documentation here, is that you essentially can use all of the native operators from Groovy. And there's a nice mapping between what they do and how they affect criteria. So for example, when you do equals, that is an equals at criteria level. When you do not equals, it's not equals. It's all very logical, greater than, less than. And you just use the logical operators. And then we have some, like in Groovy, it relates to in list, and the regex operator relates to like, and the case instance for like is the one with the single equals, yeah. So we have a logical mapping in between what an operator in Groovy and how it maps to a query. And it becomes far more concise when you write code like that, and far more logical. You see this example here. Make the syntax bigger. You see this example here where I'm saying person.where, and you can see I'm just using not equals last name, and then you can combine things with logical ands, logical ors, grouping things with parentheses. You know, it just becomes a lot more easy to read your queries, yeah? And these are all completely, the other nice thing you can do is, if on the other side of your using the regex operator, there is actually a regex pattern, if the underlying database supports it, it will do a regex like query, yeah? Do a regex query. So I think MySQL supports regex, and Oracle. Not all databases do, but quite a few have picked it up. MongoDB does, so that's quite a good thing. And you can do like between queries using a range on the right side of in. So when age in 18 to 65, you can do a range query. And you can do is null, is not null, just by putting null on the other side. Yeah, so it's all very logical. Conjunctions and disjunctions with and parentheses. You can also do property comparisons. So if you do first, if you put two properties on both, if you put a property on both sides, it'll basically map that to equals property or not equals property at the criteria level to do property comparisons, which is really handy. And you can query associations. So if you have a domain class that has an association, you just use the dot operator. So I can say pet.owner.firstname, yeah, equals, and it will do an association, a query across an association, essentially. You can also do queries on collections on the size. So just by calling the size method, you can do queries on basically size equals, size not equals, size greater than. And in the latest version of MongoDB, the MongoDB GORM implementation, we support all of these on embedded collections as well as associations across documents. And then there's subqueries where you can say find all people where the age is greater than all the Simpsons, for example. And there's functions. It's really very powerful and very flexible. And one of the nicest features as well is the ability to do batch operations, updates and deletes. So you can do update all, you can do delete all, and so on and so forth. So take a look at where queries. They're pretty powerful and pretty flexible. Some more examples of subqueries here. Probably put these in my code examples ahead of time. That would be better. So you can perform subqueries where you compose two queries together. So in this example, which I explained in one of my previous talks, we're checking for all the employees that are in the APAC or the EA region in this query, but the query is not actually executed at this point. And then when we pass it in to find all the sales that have a greater than 50,000 with employees in those two regions, it'll do at the SQL level, it'll do a correlated subquery, essentially.
Quick question. Is the ID needed there in the first query?
The ID?
Do you have to put the .id at the end? Or?
Yes, that is needed, yes. Hibernate doesn't like you just passing objects as sub. It likes the IDs for some reason. And then you can also do subqueries that have use aliases. So in this case, I'm defining an alias to the current employee, and here defining an alias to the sale, and then I'm able to compare the outer versus the inner query inside my correlated subquery. So another useful trick that you might not be aware of in GORM is formula. So if you have a property that you want to calculate based on the value of two other properties, so one way to do that is to write a Groovy method that's read-only and then do it in Groovy code. Yeah, but it's actually quite handy to do that at the SQL level, and there's a formula mapping that you can apply to any property. In this case, I'm applying it to the tax property, and that becomes essentially read-only. It's then calculated upon reading the object, which is pretty useful. I don't know if anybody's used that feature. No. Absolutely. Automatically. And also new in 2.4, we have custom column readers and writers. So on any property, you can define in the mapping a write and a read to perform. And basically, it could just be question mark, and in this case, it would do nothing. In this case, what I'm saying is I want, when it's written, for it to be converted to uppercase, and when it's read, for the title to be repeated twice. Yeah. So what you happen is if you persist a name with a title of foo, it converts to uppercase foo, and then when it gets read, it becomes foo-foo, basically. Completely useless in this case, but maybe useful in other cases. Okay, asynchronous GORM. So currently, database operations are blocking. It can be helpful to essentially isolate these blocking operations on a different thread. And I'm going to rattle through this area because I want to get to MongoDB because we've already gone through quite a bit of time. And there is work underway, like especially in the NoSQL space, to make some of the drivers out there non-blocking. Yeah. But right now, as of today, most interaction with databases, whether relational or non-relational, becomes a blocking operation, yeah, at that level. So all the rage nowadays is trying to be as async and reactive and as possible, but that's kind of hard when none of the underlying drivers support it. But it's still a good thing that we should be able to do these blocking operations in an asynchronous manner. And GORM provides that through asynchronous GORM. So one day, hopefully in the future, the MongoDB guys and the CouchDB team are working on asynchronous drivers for their databases. And one day in the future, who knows, maybe somebody will write a stable and usable SQL, but that's something that's completely database specific. So there'll have to be an Oracle asynchronous driver. Maybe there'll be an async JDBC standard one day that everybody implements, and we'll all be happy. But right now, how do we basically isolate our blocking database operations onto a separate thread? So in GORM, any method can become async. And the way you do that and the way you achieve that is just by prefixing .async in front of any GORM static method or even instance method. Yeah. So in this case, I'm creating 3 promises to execute a function, and rather nonsensically, I'm waiting for them to finish on the current thread. In reality, you would probably have an onComplete or something that actually reacts to when all the results are done. But just for the illustrative purposes, you can see that you can essentially do that. Now, that's kind of useful, but and I was going to demo it, but since we're already quite running low on time, I'll see if I can demo it in conjunction with MongoDB further along in my presentation. That's quite useful, but it tends to be too fine-grained. If you're only doing one query, that's great. But generally, doing a thread per query is probably wasteful. There is, to solve that particular problem, you can do .async.task and perform a whole bunch of operations in a separate transaction or whatever you want. You can query, you can do an update, you can do several queries. And then that will return a promise, and you can, in this case, again, I'm just blocking in the current thread completely nonsensically, or you can wait for the result, do an onComplete. But essentially, using the task method, you can perform a number of GORM operations. And notice how I'm not prefixing with person. I don't even have to. I just call the finder directly inside the task. So you get all of the GORM methods inside the task block available to you, which is pretty cool. That's GORM. That's GORM async, and I'll try and demo some of that along with MongoDB. So MongoDB. Who uses MongoDB? Quite a few hands. Excellent. So MongoDB has some fantastic features. It's very popular, one of the most popular non-relational databases. It's a documented-oriented store. So what does that mean? That means essentially that it's a schemaless store where the data is held in JSON documents, essentially, JSON representation. It's completely flexible, so you can have nested keys and documents within documents, it supports a huge amount of features, from full text search to geospatial querying, and it has a number of different ways to set it up in terms of replication and so on and so forth. I'm not going to go into a whole MongoDB talk because that's a completely separate subject. In this case, I'm more interested in discussing how it relates to GORM. In terms of what GORM has to offer, we have integration. In addition to all of the normal GORM features that exist or documented, we have specific tailored support for geospatial querying, for GeoJSON models, for full text search, schemaless domain models, projections, MongoDB specific ones, aggregation, and the stateless and stateful modes, depending on whether you're doing write-heavy or read-heavy applications, as well as custom user types. So in terms of internals and bits that you may want to have a look at inside of GORM for MongoDB, the Mongo entity persister is what handles reading and writing documents. The Mongo query instance is what hooks into the MongoDB aggregation pipeline and performs queries. The Mongo session deals with handling request start and request done in the Mongo driver, and also handles batch inserts, updates, and deletes. Mongo GORM static API is what I showed you before. It extends GORM static API and adds full text search, geospatial querying, so on and so forth. And then GeoJSON type. So we kind of ate our own dog food in this, in that as part of GORM in general, we created a mechanism for creating custom user types for NoSQL data stores. And to make sure and verify that works as way we expected, we implemented all of our GeoJSON support as custom user types, just as you could have done yourselves. So, and there's a GeoJSON type and various subclasses for each GeoJSON object for doing geospatial queries. The source code you can find at this link. It's, as I said, probably the most mature implementation of GORM outside of the Hibernate one. In terms of geospatial data, quite a common use case for MongoDB. Geodata in MongoDB is represented by GeoJSON types. It's a specification. You can see it at geojson.org. There is a package in Grails called grails.mongodb.geo, or in GORM, grails.mongodb.geo, which contains all of our GeoJSON types. So in there, you'll find point, polygon, line string, multi-point, multi-line string, multi-polygon, and geometry collection, which map one-to-one onto the GeoJSON specification types. And basically, you can do some pretty fancy geospatial querying. So for example, you can create a point and persist a particular place that lives at that point. That could be latitude, longitude data. In this case, it's just random data. And then you can create polygons. Trust me, that's a polygon. It kind of doesn't really fit on the slide properly, but it is a polygon. And then you can use methods like find by point geo within to check whether a particular point is within the given polygon. What you pass into geo within can be any polygon or multi-line string or multi-polygon, or any of the GeoJSON types can be passed into the geo within method to do any kind of geospatial querying. MongoDB also has some nice support for creating text indices. So basically, you just specify a particular field or collection of fields as being full text searchable. And then GORM has a number of handy methods, like where you can just call search for a particular term and find the results. You can search for the top results as they're categorized. You can count the number of hits for a particular search. Very similar to the way the searchable plugin works for Grails. Quite similar methods, and but instead using native MongoDB text search indices. You can also do dynamic schema list stuff in GORM for MongoDB. So how does that work? Essentially, if you have a domain class, you can just use the subscript operator, like a map, and set any properties, save that, and they get saved additional to the ones you've declared in your domain class, and they go into your documents. So you can have completely schema-less domain models. We also have special support in MongoDB, GORM for MongoDB, for maps and maps of objects. So maps and maps of objects never really worked very well with relational databases, because how do you map a map in Hibernate? So it's never really worked very well. But in MongoDB, it's completely natural to have a map of a map of a map of a map and various nested maps. And that all works in GORM for MongoDB. So that's all pretty cool stuff. So I'll do the quick demo because I've got the, oh no, just stop it. Okay. So over here, we have the same example. It's set, instead of depending on the Hibernate, I'm depending on MongoDB in my build.gradle. And if we look at my person domain class, it's largely the same, pretty much the same. And I get compilation errors if I do a refresh. refresh, yeah. There we go. So instead of using a Hibernate data store Spring initializer, I'm using the one for MongoDB in my setup spec. As it happens, I have MongoDB running here in the background. So this is a spec that's going to persist a bunch of people. It's going to notice I'm getting a reference to the MongoDB database. It's going to drop the database, and then with a new session, persist all these bunch of objects. It's good to wrap logic like this in with session. The reason why is because GORM for MongoDB is very clever about batching up operations. So although I'm doing like multiple saves here, at the end it'll insert all of these documents in one insert. Yeah. So it's not going to do MongoDB insert document, insert document, insert document, insert document, insert. It'll do batch everything up and do it all like at the end. So it's very efficient, and then we can essentially do the same querying as in GORM for Hibernate, just backed onto MongoDB instead. There we go. Now, in order to create a text indice, if we go to the plugin documentation here, you essentially can map it to particular, create an index that is of type text. So, for example, on the first name property, index, first name is a text index, and then essentially what happens is that will become maps for full text search, and then we can use various search stop, etc. to count hits, and it'll automatically perform the query against the MongoDB database and so on and so forth. In terms of MongoDB types, so as I said before, you can create a point in longitude and latitude that is of grails.mongodb.geo as a property of a domain class, and this could be like home address or something like that. You can then save a person using a point. So in this case, home address would be a point dot value of 10. You would put something more accurate there, etc. And you define your points of where these things are. And MongoDB has support for geospatial data that's on a flat plane or on a sphere, like the Earth is a sphere, right? So it's different to being, and it has, you can, once you have that data in place, you can then use the various other GeoJSON types. If we look in this geo package, you'll see that there's all of these implement the interface GeoJSON, and in fact, you can use that GeoJSON interface as a property of any domain class. And then you can pass in any of these to the query. So I can say find by person, find by home address, geo within a particular polygon. And these are all very well-documented APIs and linked into the GeoJSON spec. And you can say find by home address within a particular multi-line string, and so on and so forth. So it's very comprehensive support for MongoDB's GeoJSON support. Okay, so other implementations that you might want to check out. Neo4j can be found there, grails.org.plugin says Neo4j. I believe after releasing 1.0 of the plugin, they've now completely rewritten it for Neo4j because Neo4j has a new query language called Cypher, as far as I understand. Anybody use Neo4j here? Yes? Question?
I wanted to go back to the previous slide and just, is there any thinking about
This one.
extracting the GeoJSON from, it seems odd to me, it's sort of maybe a couple of MongoDB's implementation.
It isn't really. These particular classes are aligned with the GeoJSON spec. So anybody...
It's just a package.
Yeah. The package name is MongoDB, yeah, that's true. But as far as I know, I don't know if... Is anybody else using GeoJSON as the spec? Any other data source you know of?
Well, I think it's pretty widely used in, obviously, in JavaScript community. And what I start thinking about when I see the geo classes here are GIS and local spatial.
Yeah. Yeah, it probably makes sense to separate the geo classes into a separate shareable library. We don't have it that way right now, but we could do that in the future. It's true. Right now, most geo it's been used mainly inside MongoDB on the server side. So we'll see how the whole geospatial area progresses. I know that Hibernate have a Hibernate geospatial project, which might be interesting in looking at too, and maybe support within Hibernate, GORM for Hibernate geospatial, and these classes becoming common across both. That might make sense in the future. So yeah, definitely. Okay, so yeah, Neo4j, as I said, does anybody use Neo4j here? Not in this room. Okay. Well, it definitely has its use cases. I guess not everybody's building a social graph, but it has users, and they recently released latest version of Neo4j. The latest standardized way of querying is using a new query language called Cypher. So the plugin is being rewritten to use Cypher instead of whatever they were using before. And then Redis GORM is at 1.0. I'm not sure how much further we're going to take Redis GORM. There was a recent thread on the mailing list about folks wanting to contribute to it, and we would definitely be interested in that. The reason is because Redis is not often used in that way. It's very much a key value store. But when we initially did GORM for, when we started working on GORM for alternative data stores, we picked MongoDB and Redis as a kind of testing ground to make sure that we did two. And the way the Redis one works is it maps entities onto Redis hashes. So key value pairs in a Redis hash. But not everybody uses Redis hashes. Some people use just key value querying. It often just uses a cache. So it has very different, and there's a separate Redis plugin that is not Redis GORM that's very popular in Grails, just for interacting with Redis directly. But the Redis GORM plugin is it's 1.0 and it passes the TCK, and and there are folks who are using it. So we'll see. If we get a lot of requests, we will continue to move it forward. Then the other one is GORM for REST. So there is a plugin that implements GORM on top of backing onto a REST API. So you can map a GORM entity to a REST endpoint, and then in the background it will do a query and pull it back and convert the JSON to domain entity. That is not a full GORM implementation because obviously not all, most REST endpoints don't support querying, right? It's just list, get, put, delete, it's really just CRUD, yeah? There's no querying support, it's just CRUD, essentially. So it's very a subset of GORM. We had some discussion about adding querying by supporting MongoDB's query format. So it would pass as a query object across a MongoDB JSON format, and then that would be converted to a GORM query. And whether anybody would end up using that is debatable, so we haven't progressed that idea. And then Cassandra, as I said, is in active development. We have 2 external committers on there. So we'll see how that one progresses. Okay, so I do have time to go through unit testing, it seems, so that's good. We still going to have time at the end for questions as well, which is great. So I want to go through unit testing in GORM. We recently released, as part of 2.4, unit testing support for Hibernate and for MongoDB. So the way you get hold of that is to declare in your Grails app a dependency on this library. There's 2 versions of it, one for Grails 2.4 and one for Grails 2.3. And below. We had to do that because the unit testing API has changed again. Unit testing infrastructure. And essentially what it does is it provides a class called Hibernate test mixing, and there's another one called MongoDB test mixing. And you can essentially open any unit test, and you can specify a domain and mix in the Hibernate test mixing, and it will initialize Hibernate within your unit test. So this is quite handy because some folks don't want to go on to full integration testing just to test some SQL queries or test some interaction specific to Hibernate. And of course, we still have the normal testing infrastructure for GORM, which uses the in-memory implementation concurrent hash map. Yeah, so a lot of interaction with GORMs can just be mocked out with our in-memory concurrent hash map implementation. But this provides a nice alternative to essentially load up Hibernate, and we'll do it. It'll do it once per spec. So it'll initialize Hibernate at the class level, and then each test won't have to do that again. That makes sense. So it's one-time initialization, and it wraps each test method in a transaction that rolls back, so that you don't, so that individual tests don't share data. That makes sense. And exactly the same, essentially exactly the same for MongoDB. Instead of Hibernate test mixin, you use MongoDB test mixin, and again that will load up MongoDB, GORM from MongoDB inside the test. You can write unit tests and run them in your IDE without spinning up Grails and integration tests and so on and so forth.
So is it the underlying database defined as test?
It's an in-memory database. Yeah, so it's, well, in the case of Grails, it's whatever you define in the test scope. So it could be a real database. You just defined you got the different data sources for the different environments. It's whatever you define, basically. Okay, so basically, this talk was hopefully to give you a broader view of the diverse ecosystem around GORM. So GORM is like far more than just a ORM tool nowadays. It's an ORM tool. It provides integration with a whole bunch of non-relational stores. From Neo4j to MongoDB, from Cassandra, and hopefully in the future things like HBase, maybe even Elasticsearch, who knows. As I said, it's a great area for the community to contribute to because it's a rapidly evolving, exciting area of the framework, and so many people have told me GORM is like the killer app of Grails, and has been historically. So it's definitely an area that we are very passionate about and want to continue evolving. And as we go through towards Grails 3, it'll of course be integral to the Grails 3 effort, just as it has always been in the history of Grails. That is my talk. There's now time for some Q&A. Do we have questions?
Is there any thought for encrypting data from MongoDB?
Is there any way to encrypt data from MongoDB to and from? So yes, you could. GORM has a whole event model, and you can write custom event listeners that hook into the pre-insert and preload events. So every GORM operation has an event. So before a document gets inserted, it's pre-insert and post-insert and pre-update and post-update, and then when a document when it gets loaded, it's preload, post-load. So that you can essentially write a custom event listener. It's probably something I should have covered in the talk, actually. It's an advanced trick. Is you can write a custom event listener that basically preload encrypts your data before it goes to the database, if you want to do that. And then post-load decrypts it using whatever algorithm that you want. I'm not sure if you can do that at the MongoDB level as well. That may be possible. I haven't seen that feature in MongoDB, but it could be possible. It's a very feature-rich database, so it could be that it's also a feature you could do at the database level. But it's certainly possible at the GORM level. More questions? Yeah.
Has there been much activity on the multiple data source handling? Like I've had issues with hibernate filters and things that apply to a data source and should just apply to one.
So within the context of Grails, we support multiple data sources. I know folks have run into some issues with that, but if you have a specific issue, just bump it on Jira and say, this is really bothering me, or this is really a big issue for us, and we can bring that. If you have issues on Jira, as I said, the way our approach to Jira is we get a lot of Jira issues weekly. That's just the nature of open source projects that are used by thousands of people. And we give priority ones that have the most noise around them. Votes, people commenting, people, So that's just the way it works. I mean, unless it's an obvious blocking issue. So if you have a particular issue with multiple data source handling in Grails, we can certainly look at that. In the latest version of the Grails data stuff, I've also been adding a support for multiple data sources in standalone GORM, so you can use multiple data sources in standalone GORM, but that's not been released yet. So it has been worked on that area, but if there's individual issues that you're encountering, let us know.
I was just wondering if you had any thoughts about possible workarounds for performance issues around hazmat.
So the question is, have any had any thoughts about possible workarounds for performance issues with has-manys? So what I would say on that subject, and it's been covered many times, and it's not Grails specific, it's a Hibernate general issue, is that has-manys are only really useful if your data is small. Yeah? So anything...
The thing is, it provides some niceties. When you cut it out, you lose those niceties, and you pick a, you have to do a lot more of that manually.
Yeah.
So the cascade, some sort of cascade rules, or if you want to access the many part of it.
Yeah.
But there is if you add it, then your data space runs into performance issues.
Yeah, I mean, it's really an issue around the fact that the semantics of what a set is in Java and how that relates to a Hibernate domain model. And there's nothing that either us or the Hibernate team can do to fix that. But there are other data types. There's the bag support that we added in Grails 2.3. So instead of your has many being a set, which is the default, you can create a bag, which avoids the necessary checks on uniqueness and so on. That a set requires that there's no duplicates, and ultimately, so it has certain semantics in Java, and in order to fulfill those, Hibernate has to load the whole thing, whilst a bag has separate semantics. And I know that in certain cases that solves problems for people. But as a general solution, it's not even something that we can fix as the Grails team. It's something that would have to come from the Hibernate team. And if they spent the last, what must be 11, 12 years developing Hibernate, and they still don't have a general solution to that problem, I wouldn't hold my hopes up. But
Fair enough. That's why I love, my thought about it was doing, workarounds for, various parts of it. Not doing the has many, but maybe like writing, I was thinking about writing an ASP that we do need, like, a find, like basically meta find and like adders and stuff like that to the domain class.
so that's an interesting idea. We could, at the GORM level, we could do something around ASTs. We could even detect the fact that, this is not a real Hibernate association, and try and do some cascading of our own programmatically.
Like I said, I was just trying to
I'm
maintain
just-
some of that functionality, but without, incurring like the set problem.
Yeah. So maybe bring that up on the Grails. We have a dev discuss mailing list on Google. Not the ones we killed, the new ones.
Not the one you were talking about last time, but there's
The new one, that's the Google group.
okay.
Yes, the ones we haven't killed. So yeah, if you bring that up, maybe we can, think of something that makes sense that could be done with AST transforms. So that's one of the benefits that we have with Grails is because we have AST transforms, we can do stuff that's not possible in the Java world. Like eliminate the need for proxies altogether, for example. That's one thing that we've been on the to-do list, actually. Because Hibernate has build time enhancement, where you can run your entities through a build time enhancement process, and that gets rid of the need for Java sys proxies. So we could do that same thing, but with an AST transform. That's another thing. Yes, question over here?
Can you override or preset the ID of an entity?
Can you override? So the question is, can you override or preset an ID of an entity? Yes, you can. In the mapping of the entity, you have to change your ID generator type to be assigned, so that you are taking responsibility for assigning the ID. Is that what you want?
That line just tell you where it's going to stop. But if I'm doing insert by rows, the ID still will be increased by sequence. But for me, we have a requirement to promote data from one environment to another. So I have to keep the IDs from environment A and move to B.
Yeah.
But even though I preset, I set out the ID to assign the values, but that's if I insert 10 rows, that is not going to guarantee every row has the same ID. It only guarantee the first row start with the same ID.
So it sounds like more of a data migration issue than something specific to GORM. So if you're manipulating your data behind GORM, that can sometimes, especially with sequences, and it might be better that you do what your work you're trying to achieve in a migration. Have you tried the database migration plugin to do that? That's one option to do, because you're essentially migrating data from your staging environment, is that right? It sounds like more of a job for your database migrations scripts with the database migration plugin, rather than a job for GORM. Yeah? Question at the back?
So I have a custom type that basically just converts a Boolean into a particular character at one point, and converts that character into a Boolean and use it. So could I just read and write routing to do that instead of having a custom type?
So the question is, you have a custom user type and it does some conversion. So let me think. Yes, you should be able to. It just depends it just depends on your database and how good your SQL foo is. Because ultimately those read and write strings are just SQL. So if you're able to use SQL functions that do what your Java code did, then you can do whatever you want, if you see what I mean. So
could I also use that to get like a blob, a link of a blob, without having to have that blob, like call a function?
you can call, yeah, inside those you can call any functions, or Oracle. If you're using Oracle, you can call any Oracle functions. It's essentially embedding into the SQL something that will be executed when reading or writing that. So that's what all it is. So you can. Yeah. There was a question over here somewhere. Did I see a hand? No? Okay. Any other questions? Okay. Well, thank you very much.